This video shows how to create a flanged beam column joint in the structure shown in video 10, which discussed importing a FEM model into CSE and searching for JNodes. JNode AA, which we will consider here, is hierarchic and has no attachments. Let's look at the renode associated with JNode AA, which is the only one currently selected. The JNode occurs several times in the structure, but we only need to build and check one of its associated renodes. Initially, only the members are present, and because no offsets had been defined in the FEM model for one of the two beams, this one overlaps the column. We will now trim it, and CSE will automatically add the necessary moments of transport into the computation. We add the flange. We weld the beam to the plate. We apply the bolt layout. When the face on which the screws are to lie is selected, CSE automatically recognizes the objects to be drilled according to their position. We choose the bolt diameter and class, and we specify how they are arranged. We want the bolts to work on a shear and tension basis. We insert the layout. We now add the first stiffener to the column. We move it into position. If we do not yet know the precise distance, we can inspect the distances between the significant points desired. We add the weld layout to connect the stiffener to the column. Now we select the stiffener and the weld layouts, and we create a copy of them. We select both the stiffeners with all the weld layouts, creating copies of them on the other side of the column. We now insert the plate to which we will bolt the second beam's web. Its connection to the column will not be flanged. We weld the plate to the stiffeners and to the member's web. We add the bolt layout to join the plate to the web of the beam. We check the connection for consistency. All the components are connected correctly. Next, the chains are shown. These are the possible paths between the slave members and their master. The settings for the checks have already been specified. This dialog box is used to choose, among the other options, the reference standard, the safety factors, the methods of computing the internal forces, the checks to run, and the checks on the component shifts. Let's check the connection. The checks have been completed. The results listing, if requested, is shown automatically, and now all the post-processing commands are available to analyze the results. We can now see the utilization envelope for each entity, for all combinations and instances. A battery of checks has been run. Strength checks on the various bolts and welds, bearing stress checks on all the objects pierced by bolts, and the checks on the net sections of the members. For this connection, we have not checked the compression between the plate and the column flange, nor have the entities been checked using automatically created FEM models. For both these aspects, please see the previous video.